Yeah, our solution to this problem is BuckeyeBoard, and this is our team. So the main problems we're addressing is overcrowding and uncertain bus capacity, lack of real-time context awareness, and limited multimodal and accessible guidance. So our solution, we have a hardware side that incorporates ESP32, and also in the software, we have AI decision engine. So mainly we're trying to address the efficiency, adaptability, and the sustainability portions.
So this is the hardware side of our project. So as you can see, as people come and sit, the 4 sensors under the seat register and decrement the amount of seats available, and that will display on our software side as well. And it also, as more people enter, it'll also update the capacity available using the lights and our software as well. And once it reaches max capacity, it'll turn red. And as people exit, it will also continue to update the availability using the lights and the software side. Yeah.
So this is what our software dashboard looks like. So on the top, you can see there's 0 active routes, and that's because I'm currently at the physics research building and I haven't selected where I want to go yet. And once I do, that number will increase. And if there's also buses running near the location I'm at, that will change. And you can see there's 5 live buses, and this is directly taken from the OSU CABS API. So you can see there's 3 buses on Med Campus and 2 running on North. And then there's 25 seats available, and this is with the total capacity of a bus and using the pressure sensor. This is just the simulated value right now, as well as the carbon saved. And this was calculated by the amount of buses running and how much would be saved by people using the bus system instead of driving cars. So it's just a nice positive number to have. And right below that, you can see the weather. And this really comes into account when it rains or snows, because that will increase the demand of these buses and they will be more packed. And this goes into consideration when you want to pick which mode of transportation you want to take. So right now I'm at the physics research building, but if I wanted to change that to if I'm at the stadium and want to travel to the Union, and if you don't want to type it in, there's also a map where you can select the buildings instead. But if I want to go to the Union, I can plan my trip. And this analyzes the weather. So right now it's good conditions, and it also analyzes crowd levels. So higher times of day, such as OSU follows a standardized class schedule. So 8 a.m. to 8:55 and 11:30 to 12:25 classes. So it has all those into account that it looks at, as well as live bus data. So the capacity of these buses. So if I'm traveling from the stadium to the Union, you can see the amount of time it would take me to walk, and also has ETAs under each of the modes, as well as if I took the CABS bus, it also tells me which buses I can take and where I need to get on and off, as well as if I wanted to take a scooter, it also has an estimated price, as well as a cab or lift. And there will always be an AI suggestion, which will suggest the fastest way, but that doesn't necessarily mean you have to follow it. And right now you can also see under the smart stop status, you can also see the 4 buses closest to me. So if I'm at the stadium, these will be the 4 buses.
And this is a CAD model. And this is the tech stack we used.
We hope to implement this in the future by using the data for more mobility ways.
Thank you.